Alright, hello and welcome to the lecture portion for ionic bonding. What our plan for today is we're going to go ahead and review what ionic bonding is, and how you can conceptualize it, and how you can tell if something ends up being ionically bonded or not. There's a total of 4 bondings that we're going to be concerned with in this class. Ionic bonding is usually the most simple one. We're also going to be covering covalent bonding, coordinate covalent bonding, and metallic bonding. And metallic is also really easy. So without much further ado, what we're going to do is start here with ionic bonding. Let's restart this. Alright. Okay. And in ionic bonding, we need to keep in mind a couple of things about the atomic structure. The first thing about atomic structure is that we want to go ahead and remind ourselves that there's only one orbital per period. That outside orbital is going to be our valence shell, and that's going to be the most important one for ionic bonding right here. Because that valence shell, or that outer shell of electrons, is going to determine the properties and how these different things bond. The innermost shells are usually not going to participate. So the innermost shell has 2 electrons, all the other shells have 8. And that 8 number is going to end up being really important for us in terms of bonding, because in general, when we bond, we want to try and make sure that we have 8 electrons in our outer shell. Okay? And to help you guys out, I also like to say that it's either 8 or 0 in the outer shell, because what you're going to see is that some atoms are going to lose electrons, and they will lose from their outer shell until their outer shell has 0, or they're going to gain electrons, and when they gain electrons, they're going to gain until their outer shell has 8. The notable exception for that is going to be hydrogen. Hydrogen, since it only has 1 electron, and it only has 1 energy level, will only gain 1 electron and have 2 total electrons. So that's the only notable exception I want you to take note of. Okay, so first we're going to go ahead and define what an ion is. And an ion is going to be any atom where the number of electrons and the protons do not equal. So atoms can gain or lose electrons. They can't gain or lose protons, but they can gain or lose electrons. And when they do, they're now considered an ion. Okay? And again, it's only those outer shell, the valence electrons, that are able to be gained or lost. When an atom ends up gaining or losing an electron, it will now have a charge. Because remember, we used to have the same number of positive charge and the same number of negative charge. So if we add more negative charges to the atom, it is now going to be a negatively charged atom. If we take away some negative charge, the atom will now be positive because it has lost some of that negative balance. So atoms end up being in balance initially, and then we end up losing that balance when they gain or lose electrons. So this here is an example where we have a sodium ion, and normally sodium has 1 electron in this outer shell. However, it has lost that to chlorine, so it has lost 1 electron to chlorine, and then that chlorine has now gained an electron from the sodium. The sodium now has a positive charge, and it is now an ion, and the chlorine now has a negative charge, and it is also an ion. So both of these are ions because they're charged. Sodium lost a negative charge, so now it's positive. Chlorine has gained a negative charge, so now it's negative. Okay. So if it has the same number of protons and neutrons, it's considered neutral. If it's negatively charged, that means that it has more electrons than it does protons. And if it's positively charged, that means it has more protons than it does electrons. Okay. Now, each time that it gains an electron, that's going to change its charge number. And if it loses or gains 3 electrons, that means it's either going to have plus or negative 3. In the case of calcium, calcium will often lose 2 electrons, so it will have a charge of plus 2. Okay, so next is going to be the question, how do you know if it's going to gain or lose electrons? So if it is a metal atom, it is going to lose electrons. So anything that's on the left side of the table that ends up being a metal will lose electrons. Whereas all the non-metal atoms will gain electrons. Okay? In general, the rule that states how many electrons they're going to grab is going to be the octet rule. And the octet rule is, well, to be honest, it's kind of like the rules that they have in Pirates of the Caribbean for the pirates. It's a rule, and yes, it exists, but it's kind of more like guidelines. Okay? So the goal is to have a full outer shell of 8 electrons. Okay? In general, if it only has 1 to 3 electrons, it's going to lose those electrons to something else. Okay? So your metals typically only have 1 to 2 to 3 valence electrons that are hanging out there on the outside. So they tend to lose those electrons. If it has 4 electrons, it could go either way to make a gain or lose to get to 8. Okay? And remember, to help us think about it, we can think about it getting to 8 or to 0. Either way, it's going to end up being the same, have the same kind of feel. So if it has 4, it could go either way. If it has 5 to 7 valence electrons, it's going to take electrons in order to make it get to 8, which kind of makes sense. If it's already almost to 8 electrons, it takes less energy for it to grab from somebody else. The last thing is if it already has 8 valence electrons, it will not lose any of those electrons. So the noble gas elements, in general, do not lose electrons because they already have 8 electrons. Here we have an example. We have magnesium and oxygen. And magnesium, right here, has 2 valence electrons, and oxygen has 6. Magnesium's a metal, and oxygen is a non-metal. So the electrons from magnesium are going to go ahead and go to the oxygen, which means that the magnesium is going to have a plus 2 charge, and the oxygen will have a negative 2 charge. Okay? And then they will end up combining together to cancel out their charges, which means that this compound will now be magnesium oxide. When we have ionic bonding, it's exactly what we saw before with that production of that magnesium oxide. So when this happens, this forms our ionic bond. Okay? Those opposite charges, so that plus 2 and that negative 2 on our previous example, attract each other, and that attraction is what is that ionic bond. So because they have that negative and positive interaction, just like what happens with magnets where we have a negative side and a positive side, they attract together and we get that bond right there. And notice that this is like a full-on charge bond. We'll go into partial charge bonds in a little bit. Okay, so our classic example is using sodium and chlorine. Sodium loses an electron to chlorine, which means that sodium is plus 1 and chlorine is negative 1. That causes an electrostatic attraction, So, positive and negative go together, opposites attract, and they bond and they make sodium chloride. Okay. Now, when they do that, that's going to give us a new product that has very different properties. So, as we said before, sodium is a metal, okay? And it's a fairly soft metal. It's really reactive with water. And chlorine is a gas, and it's a poisonous gas, and it was used in World War II to poison people. Okay? When we end up combining these two together, we end up getting sodium chloride, which you guys know as a salt. So we actually get a new product with different properties. Okay? And the properties for most ionic compounds are going to be fairly similar. They're going to have different toxicities and different chemical properties, but for the most part, a lot of the properties or the physical properties are going to be pretty similar. So the ionic compounds have very orderly structures, and they make crystals. So if you think about salt crystals, that's because ionic compounds, because they have that constant negative and positive charge, are going to make orderly structure, and they always form crystals. Because they have a really, really strong bond, in those crystals, they have really high melting points. Okay? They conduct electricity really well when dissolved in water. They also conduct electricity really well when they're in liquid form. They're the strongest bonds that we have between the atoms, and that they only occur between a metal and a non-metal. They have a high melting point, low vapor pressure. They are brittle, which is why you can use them in a salt shaker. They're poor conductors as solids, great conductors as liquids, and then they easily dissolve into solutions. You can usually dissolve salts, which anytime that it's a metal and a non-metal, I'll slip up and say that it's a salt. But salts typically dissolve really well in water, and those are some properties that you should know about all salt. It's going to take a long time to melt salts. Okay, so now what you should be able to do, you should be able to determine the charge of the atom when it's in an ionic form, determine how many electrons an atom will gain or lose in a reaction, determine how an ionic bond occurs, and then list and draw the properties of ionic compounds. Now we're going to go ahead and add one other function to our thing here, where I'm going to go ahead and tell you the easy shortcut way to determine how many electrons on that outer level that it's going to be able to gain or lose. So right here we have our P table, and notice that our P table is separated out, and this one has all the colors. Everything that is in this blue zone and to the left are all metals. So all of these are going to end up losing electrons. When we go to count how many electrons it's going to lose, in general for ionic compounds, it's going to be 1, 2, then we're going to skip these few. Now these are going to lose a variable amount of electrons. 3, and then if it's tin or lead, these can lose either 2 or 4. And bismuth can lose up to 5, and polonium can end up losing up to 6. So to count how many electrons a metal will lose, you'll go 1, 2, skip these few. You'll skip the D block, because the D block you'll often have to be told. 3, 4, 5, 6. Okay? Now, if you're doing it the other way, you would start right here. Okay? And this is going to be 0. Okay? So these are never going to take any electrons. Well, I don't say never because, the rules or guidelines. 0, 1, 2, 3, 4. Okay, and that's how you can tell how many electrons that are going to be exchanged between those right there. Okay, this is going to end up closing out this section for ionic bonding, and be prepared to be quizzed just a little bit. We're going to be working both on formula building in this section and then also determining what the ionic charges are going to be.